Okay, next we're going to look at binomial distribution, and how do we know if we're doing this? Well, one way is we have 20, say, transistors that we're going to test to see if they're defective, and we have a percent. So binomial distribution, you always have a percent. Now again, it could be that 2 out of 10 people get sick and you can figure out the percent yourself, 20%, and 80% don't. Or I could just give you the percent. Binomial has to be 2, so yes, no, heads, tails, sick, not sick, defective, not defective, something like that. And the other thing that makes it different than A3 is all 20 transistors are in the problem. So if I say probability that exactly 5 test defective, I'm not choosing 5 of them. I'm choosing all 20 of them. It's just I want that 5 are going to test defective. So it's not, you're not taking a sample of this. The sample is all 20. And so basically it could be defective, defective, all these defective, 5 in a row, and then all the rest, right, are good. So we could have 5 bad and 15 good, and that's how many ways that could happen. But again, it could be defective, good, 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 defective, 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 some good ones, defective, and then all good. Or it could be all 15 good at the beginning and all the defectives at the end, or any combination, I don't know. But the idea here is I'm not just grabbing a sample of 5 and saying, ooh, I want 2 red and 3 yellow. All 20 are in the problem. Okay, so let's look at this one. So I want 5 defective. Okay, so I'm going to have 20 total. Everybody's there. And I want 5 to be defective. Now, in this case, success is the fact that they're defective. Okay, so success doesn't have to be good. So defective has a probability of 5%. If I subtract from 100, that means 95% are the good ones. So I want 5 defective, and I want the rest to be what? Good. Okay, and so that's kind of how that is going to be set up. And so on my calculator, I am going to go to, let's see, what do I have? A combination. So you're going to do, let me clear this. I'm going to do 20 math, go to combination, and I'm going to choose what? 5 times 5% raised to the 5 and then go down low again on some calculators, and then I have what? 95%, the rest of the 100%, and the rest of my 15. But again, all 20 are there. So I get 0.002, or about 0.2% probability of that happening. All right, let's look at the next one. Probability that there are no defects. Okay, so that either means they're all good or you have no bad ones. So it kind of depends on how you want to think about it. So if I want to have no bad ones, and so 0 again is defective, is what I'm focusing on for success, then success would be that I have none defective, and all 95% of them are actually going to be good. Now, I could change how I define success. So I could say that success is that they're all good. So good is success. Then my exponent on good is going to be 20 because that's success. And my exponent on failure is going to be that they're bad is 0. Notice that these are just flip-flopped. Now these, you might be like, well, that's going to give you different answers. It's not. Because if I have 20 and I choose a combination 0, I get an answer of 1. And if I have 20 and I do a combination of all 20, there's only one way to do that. So either way, it's going to be 1 for that first part. So it doesn't matter because these are actually the same. So focusing on defective and having none of them defective, all good, is the same as focusing on good and having them all good and none defective. So I'm going to take my 1 times 0.95 raised to the 20th power, and again, the order doesn't matter on this one, raised to the 0 power, and you should get about, what is that, 35.85%, okay? So that's going to be 0.3585 or 35.85%. Probability of that happening. All right, and again, if there's at most or at least, we have to think, right? So if I want at most, right, then I would be okay with what? Probability of 0 of them defective, probability of 1 of them defective, and probability of 2 defective. And again, this is a probability of exactly 0, exactly 1, and exactly 2. Now again, how do I know not to do what we did before? So some of you are like, why aren't you doing like the leftover slots like we did before, right? Well, there's a lot of reasons. Number one is I have a probability. I have success and I have failure, and it's 5% and 95%. The other reason I'm not doing this is because, remember, this is the total, like the vague on bottom, but these are specific where you're only picking, say, 5 marbles or 5 apples, or, you know, 5 of lemon, lime, and cherry, and whatever. So here I'm picking everybody, and I have percents involved. So totally just different problems. All right, so let's line these up. So 0 defective, so I have 20 and I want 0. So again, I'm defining defective as success. So that means my probability for defective goes with that exponent. And then the rest are all good, okay? The other thing that could happen is exactly 1 defective, okay? So 20, choose 1. And again, success is their defective, which is 1, and the rest are all good. And the last one is I could end up with 2 of them defective. Again, my probability for defective and the exponent goes with there, and the rest of them are all good. Okay. All right. So let's see. I think we just did this one. This would be the no defective, right? So we've already done that math. 0.3585. All right. So let's do this one. So I have 20. Clear 20, and I'm going to go to math, probability, pick a combination, and I'm choosing 1 times 0.05 raised to the 1 times 0.95 raised to the 19th, and I got 0.3773, and then let's do this one. So I have 20 math, and success is that 2 of them are defective. So times 0.05 raised to the 2nd power times 0.95 raised to the 18. So for that one, I got 0.1887. And again, on an or situation, at most, at least, whatever, you're going to add up. So I'm going to add those up. So 0.3585 plus 0.37, and again, my 7 kind of sticks, plus 0.1887. And I get 0.9245. So better than 92. So if I combine these and multiply by 100, so about 92.45% probability. Okay. All right. If you'd like to do the individual ones on a calculator, there is a key. So if you go to second and distributions, it's right there, and scroll down to Binomial Pdf. Now you have to remember kind of how to set it up. Let's do this one, or do the top one. So 20 is my total, so you got to put how many. Then you have to put your probability, which is what? Defective is 0.05%. And then you have to pick how many you want. So total, success, and how many successes you want. And that will give you that one right there. And then here, I could do the same thing. So I go to second distributions and again scroll down Binomial Pdf. And I have 20 total, and let's say we're doing this one again. So 20 total, choose 0. So 20 total, comma, how many I'm picking, 0, and then my success rate, which in case here success means there's something wrong. Oops, see, I messed up. What did I do? Oh, I typed it in wrong. That will do it. Sorry about that. Go to second distribution. Put my percent second. All right, so I have 20. Put your success percent next. And I think here I wanted 0 of them to be defective. And I got that percent, which matches that. So here you could do those 3 times and add up on your calculator. But I like Desmos a little bit better for this, I think. So why don't you pause? I'm going to pause for a second, bring up Desmos, and then we'll look at that. All right, so I brought up Desmos graphing, and you can do binomial dist and put parentheses. And again, I can do 20. And it prompts you, which is nice. Success probability, we're going to go with 0.05. And then we're just going to end it. And so you have how many total, and then success. And then I can do this, find cumulative if I want between there. But notice that when we had exactly 5, that was our answer. When we had none defective, that was our answer. And then when we wanted at most 2, I'm going to unclick this guy. Well, maybe, oh, I think I'm clicking the wrong one. So at most 2 would be 0, 1, and 2. And notice when we added those up, we got the, I think, was that our 92 point something? But notice I can come over here and I can say 0 through 2, and that's that 92.45% we got. So I like Desmos a little bit better for that. Your calculator can add it up. The problem is it always goes to the left. So if you want, say, what's a probability, and again, there's some stuff you can't see here. I should minimize because there's all 20, right? The other thing on Desmos is, say I want the probability of maybe 18 through 20 of them. So 18 of them defective through 20. So if it adds up, right, like, you know, it's not going to happen. Say I want 7 through 20. So maybe that there's 7 defective. So this would add up 7, 8, 9, 10, all the way to 20 being defective, right? And that would give you that really low probability. All right, I'm going to give you your homework for this. And again, you can turn this into Blackboard for class. So I'm going to pause for a second and then I'll bring up your assignment. All right, so this is your homework for this part. All right, so male colorblind rate is about 0.042. So about 4.2% of males are colorblind. So say there are 53 men at some meeting, okay? I want you to find the probability that exactly 7 men are colorblind, so exactly 7. But again, all 53 are at the meeting. So you just ask, who's colorblind, right? Exactly 7 colorblind. Then the probability that no more than 5 are colorblind. So no more than 5. So can't have 10 of them colorblind, no more than 5. Okay, and be careful, don't forget about 0. And then at least 1 is colorblind. Now be careful on this one because you have 53 people. So you probably don't want to add up 52 different numbers, right? You know, that doesn't sound like fun. So think about an easier way to do this one. And I'll give you the hint. Remember the complement that the probability of an event plus the probability of not the event happening has to equal 1 or 100%. Okay? So if you want, this is my group of 53 people and you want to count all these colorblind people, right? Or probabilities that 1, 2, 3, 4, 5, 6, 7, all the way to 53 of them are colorblind, this might make it easier. I mean, you could add all 53 up. Well, it wouldn't be 53, it'd be 52 of them up, but that doesn't sound like fun. So maybe use this rule, see if that can help you. So again, here's your probability of colorblind. Figure out the exactly 7, no more than 5, and then at least 1 has to be colorblind. And again, using the complement rule might be super duper helpful there. So this is your homework on the second video, and take care, and I hopefully will see you guys on Tuesday. Bye-bye.